Morning, everyone. So my name is Kgotlelelo Masenamela, aka KG. So today I'll be talking about how random is random. So we've all said the word that was random or something like that. So you can define random in many ways, but okay, yeah. So for me, I like playing with randomness. It's one of my favorite things that I like to play with. And one of the main reasons I don't like gambling. So in Java, that's how you implement randomness for simulation or whatever you want to do. My favorite one is coin tossing, where my even numbers are heads and odd numbers are tails. Then I check the distribution of random, how random, yeah, coin tossing is. So what is random? So in terms of numbers, I'll say any number that is generated in a way that is completely unpredictable. So in terms of computers, then we start to have problems because computers cannot generate random, because whatever you give to a computer, you need to get the same output if you're giving the same input. So then how do we actually trick computers to give us random numbers? That will be the question of today. So it's difficult to generate random numbers. So we rely on entropy, the degree of disorder or uncertainty in a system. So if something is truly random, we need something that has the maximum entropy in that system or the maximum chaos that we have. For example, a fair coin toss. So we have two types of random when you're talking about computers. We have perceived random, then we also have something we call true random. So when you're talking about perceived random, is when we use algorithm to simulate randomness. So for example, in the linear congruential generator, we have a state or our base number from where we can generate sequence of numbers. Therefore, for example, if a hacker has the seed, we call it the seed, that state number, they can actually predict the next numbers which are going to generate in a system. So imagine you are doing slot machines, then someone knows your seed. So people are going to make a lot of money and you're going to go bankrupt. So, yeah, so therefore, people are actually bad at creating random sequences. So from the panel, I want you guys to think about 5 coin tosses in your head. Yeah, therefore, I want you guys to think about a random number from 1 to 10, and also think about 3 random numbers. From the coin toss, I think majority choose head as their first coin toss. I don't know if I'm thinking, yeah. Therefore, you chose tail, maybe the second one. So that's what we call the gambler's fallacy. So what happened is that random doesn't mean mix, or yeah, it doesn't necessarily mean mix. So what people think is that since we have so many heads, what's gonna come up is gonna be what a tail. Like we think that we are due for a tail, or maybe you're playing roulette, so it falls on the black for 5 times. Then you think that the next one is gonna be what? It's gonna be red. So it doesn't work like that. They don't have memory. So also you know that God doesn't play dice. It's all up to chance. So it's not about you praying that it's gonna fall in red. So when you toss a coin, doesn't matter how much heads they were in the previous, they don't determine the next coin toss. The chance is still what? 50-50. So one thing I realized playing with randomness is that randomness has patterns, which when you're gambling, you might say, I'm having a streak of heads. Then from there, you might have a tail or a streak of tails. So we have these unlogical patterns that we have in random processes, that where people think that, that where people take them to the gambler's fallacy, that since I'm having this streak, it's gonna be what, a head or a tail in the next process. So how can we solve the problem that we had of pseudo randomness or perceived randomness that are generated by computer? One thing what we can do is have a hardware that emit a sound or something. From there we can harvest that sound and convert it into a random number from 0 to 1, so that our hackers cannot have the seed that we have. So we can also use electronic noise, radioactive decay. So with the radioactive decay, because we don't know when the nucleus is going to decay, because it's a more random process, we cannot predict or tamper with that process. We can use it and from there generate like a random number which we can use. Therefore, Intel also has its own random RD-RAND, which is in their CPU. Some of the PCs have it, so they can actually return a random number from that CPU. Or we can also use atmospheric noise, because we cannot temper or predict the noise that's going to come up after. So what are the use cases of randomness? So in our case, we're going to have gambling for slot machines. You definitely don't want to use pseudo random there, because people can actually predict your next number if they have the seed. So if you are in games, you can create a dice game where you can use randomness. Shuffling of cards, you can also use random there. So the important thing is cryptography, encryption. That's why we're gonna need the highest entropy for encrypting. Maybe you only create your SSH. Sometimes when you create your SSH, they will be telling you that you need to move your mouse. So what is happening is that they're taking maybe the randomness of how you move your mouse clicks, the amount of data that you've collected throughout the day. So depending on your PC, sometimes the packages that you send throughout the day, they take from there and other factors and combine them together so that they can determine randomness to generate your SSH key so that it can become unpredictable. So yeah. So in Java, the method random, that's pseudo random. So unless you just want to play with your code, you can use method random. So for simulation, we can use the utils library. Therefore, that's where you can use simulation. But the utils library is not good for encryption. So we're gonna use security, secure random. And from there, that's where you can, when you're working with encryption in Java, you can use that library. So yeah, we realize that in computers, it's very difficult to determine randomness or whatever it is that you see as random, because computers, they are deterministic. I mean, when you press a button, you need to do one thing. If it's doing something else, it's a bug. You need to return, one thing at a time. So they say when you want to create randomness in software, you're in a state of sin, because computers need to be deterministic.